He's in the danger zone. Wasn't that a song? All right. Cool. There's this one. You can find a sharpener. I don't know why anybody's.
Thank you. I appreciate it. I think all mine are just sitting on my desk.
Now, I will say this. That's the most number of pencils I've seen in a long time in one book bag.
That was a very big pack of mechanical pencils.
So you've been borrowing and stealing from her all semester.
I'm not. I've been stealing, yes.
Okay.
Not borrowing.
Stealing.
Occasionally
Well,
I'll go to grab the field book and I'll just pocket a pencil by accident.
at least you're admitting it. Okay. So, crap. I don't want a new page. I want this page. Expand out. No, wrong one. Where the hell is Lab 10? Okay, so let's talk about what's coming up, because here's the stupid. It's Halloween. There's a ghost in here messing with the instructor station. Oh, no. You know what the problem is?
That's cool.
It would help if I plugged in the... Fix it. All right, so next week is building layout. Okay. This is a very interesting lab because you have to do all the work ahead of time to get all the numbers right. And then you go out and you take a fill station and you drive some stakes in and lay out the building. When we get all done, we do some diagonal measurements on a couple corners, which I will not tell you which ones they are. But you got to lay out the building. Should be 90-degree angles. They should have whatever it's supposed to do. I'll show you the picture here in a minute. But you will want to get Lab 10 out ahead of time. Okay? And you're going to want to do this. So this lab applies to chaining and total stations. So literally you're going to set your station up over the hub or stake, because we're going to use stakes. And then you're going to chain from this stake to the next stake. And you're going to use the total station to shoot your angles. So far, so good? Okay. Now, if it was only that easy. Yes?
So you would set up your total station, point to a peg you had set up and zero it, and then swing it 90.
Yep, but I'm going to walk you through the whole thing here with some visuals, hopefully. All right. Field book entries are made in the office and then used in the field. So when you're doing layouts, your real trick to a layout is it's done before you get to the job site. So there's no architectural plans that have been given to you just and you go out and you figure it out. This is architectural plans are given to you. You sit in the office and figure out what you're going to do, how to plot this out, and how to get from point known A to the next point that you establish to be one of the corners of the building. And then from there, all the corners come off that one.
Already writing anything down while we're out there?
Pretty much no. Unless you royally screw it up. Okay. Angles of distance are laid out rather than measured. So you're not doing what we did, not yesterday, 2 labs ago when we were up there chaining the triangle. You're not doing that stuff. Can you check that on your little thing, like 3, 4, 5 triangles, and make sure things are 90 degrees? Oh yeah, but you're not really chaining for the sake of chaining. You're just chaining to get from stake 1 to stake 2 to stake 3 to stake whatever. Okay. All right. What you need is a total station, tripod, level, plumb bob. Brett wants to take a plumb bob with him anyways. Sure, the plumb bob is really going to be handy, except on the chain, because you're going to be up off the stake, and it might come in handy. Well, you're going to be, one end is going to be at the top of a stake, and the next one's going out to where that stake should be. Okay, and that's where the plumb bob comes in handy. You're going to need 11 stakes, which Mr. Ryder will have on the back of the Ranger for you. A sledge, or that 8-pound engineer hammer. A lumber crayon. We're using magic markers nowadays. I guess they're not magic. Permanent markers.
So you're running the strings to the nail on top of the stake?
Yep, more or less. A hand level, so you know where you're shooting at because you're using a chain to measure distances. You want the hand level. All right. Every member of the party must prepare staking notes in their field book following the example on page 10-5. I'm going to go walk through it here with you. This involves a series of setups and angles. And when you get all said and done, you will have all the things you need to go out and do this ahead of time. Okay. Now,
no party chief again.
what's that?
No party chief again.
This one, no. Somebody can be the party chief to direct traffic out there, but pretty much no. Okay, so we're going to put PK nail in, and I still didn't look up what PK, well, somebody did. PK. Stretch the chain between stations and mark the keel point at point A. Yeah, we'll go through all that here in a minute and make sure you understand what you're doing. And this is a good one. It's a good thing it's been raining because the stakes will drive in easier. If not, it would have been a real nightmare up there. All right, grading. Oh, so grading, this is unlike anything else. Your field book will be graded before you leave this room. No, not today. No. Next Thursday. When you walk in with it, Mr. Ryder's going to want to see them. And he's going to record that you did all your numbers, got them all done. Then we're going out to actually prove that your math is correct and see how accurate you were. Okay.
Does everyone in the party have to have the same
Numbers?
Do we have to agree on something before?
Well, it would kind of help not have fights out there.
I mean, the books for the grading don't have to be.
No, for the grading part, no. But to decide which numbers you're using, you want to, who's got the best math? Yes, Landon.
You know how they have like the string levels you can hang from the string? I wonder why they don't make that like you can hang on a steel tape. You know what I mean?
Yeah, I know what you
That'd
mean.
be just as accurate as the sight level, even to someone neat.
Yeah, but the sight level is, you don't have to be walking down the chain to actually do it.
Yeah, but the group has 3 people.
Yeah, if you got 3 people, sure. Most surveying parties are 2. Okay, point systems in here, so you can see what you're getting graded on. Let's get to the, stop that. Let's just scroll up to the picture. Okay, don't be a jerk. That one page left blank. Oh, goody, and it's sideways. Okay, so literally what you're trying to fill out is this page right here, sideways. Sorry, I'm not going to frog around trying to flip it right now. You have station A, B, and C, and then you got sighted stations, and you got all of your stakes on your layout. Okay. Actually, I can't take that way. It's driving me nuts. Let's do this. Document camera, please. Oh, that's the problem. Okay. So, that was yesterday's off Olivia's book. Yes. What I want. Okay. So, sighted station, you're going to start on the road, and I'm going to pull that up on the other sheet here in a minute. And you're going to get a position. Hopefully, the station's got an even number. But Mr. Ryder's been devious. And then the other fact I hate to tell you is since last year, Facilities has planted trees on half the site. So there's a whole bunch of little pine trees trying to grow next to the service road on the south side of the road. And last year they 3 in. This year they got 6 in. So we may have to reorient this a little bit, but you will start on the service road. That's going to be station, in this case, 12 plus 00. But you could get 12 plus 4, 5. Okay. Just to be a pain.
What's wrong with 90-degree corners?
Nothing's wrong with 90-degree corners, but it does make life a little more interesting, don't you think? All right, so station B is going to take you to, I guess I do need this slid over just a bit. So here's your service road down here. A will be 12 plus 00. You're going to shoot an angle to B. B becomes your first measure, grab the stake. Okay? Which is really funny because you are going to juggle, let's say this nicely, you're going to juggle somebody on the total station, someone out there with the chain, someone holding the other end of the chain underneath the total station at the station of 12 plus 00 or whatever your station number is. Shooting this angle, you can shoot it here.
How come you wouldn't shoot to the corner?
Because it's too damn easy. Yeah, this is set up to be purposely interesting and not where I would shoot to a corner if it was me. But what also does is B and C establish your baseline.
Could you explain one more time, starting at A, how to get to
Sure.
the point?
So you're going to find where the station is. So that's going to be marked out on the center of the road up there. And from there, you're going to tell us what's this angle that you have to shoot either from a foresight or a backside from the next station. Okay? So you basically establish this baseline, and then you're going to rotate the instrument clockwise and get a reading. Okay? So let's just say it's 120 degrees. Okay? 120 degrees, and then we want to know from A to B what that distance is going to be. And the distance from A to B is 35.8 feet. Okay. Oh, it is 120 degrees too.
Where did the 58.71 come from?
That's establishing your baseline in your someplace.
What are you zeroing the instrument to?
The road.
The station numbers.
Oh.
Okay.
Because you're going to line up with the road 0.
Yep.
120
So
degrees.
everything from thick line C to G is parallel to the stations of the roadway. Okay. So what you're trying to do is, okay, remember geometry enough that the interior angles on two opposite of the parallel lines are equal.
Or the BAs will be 120 degrees also.
This would be 120, that'll be 120. Okay. Now the real fun to this is you can be here, but once you start surveying in the middle of the road, 3 o'clock up here, the maintenance crew tries to drive through. So you got a little bit of time to establish where your instrument is for the first shot and get the hell off the road. Okay? They want to run you over. If it's a real construction site, not a big deal. Okay? Because you're going to have right of way out there. But in this case, you won't. Then you're going to go from A, and you're going to shoot all the angles that you can from A. And then the distances that you need to measure. Okay. So far, so good? All right.
We move into B. So you're shooting
And you move to B, yep.
So you give us the distances from C to E and B to C?
Nope.
Interesting.
No.
We all shoot in the same.
So we don't have dimensions of it?
You're shooting the same building, just different locations. I know what you're asking, Landon, and I'm not. I don't see it here in the lab manual. Oh, yeah. No, these distances are what's given because B to D. Oh, you can't see what I'm looking at. B to D. B to A, so you shoot a back sight. Shoot 60 degrees B to E. So B to E is 17 feet. Okay. And then you're going to go B to L here. And that's going to be 24 feet from here to there. Okay. You stay at B and shoot them all. Okay. So what you're really doing is this. Let me switch pages here for a minute.
A to shoot B, then from B we do everything else.
Yep. Let's go through this on the map here.
That guy's kind of weird. Like, so if you zeroed in on your baseline from B, and then you wanted to shoot to the far corner, but you're not at the corner, so the map to find that angle will be harder.
Mm-hmm. Yeah. And he wanted to cruise through to the end of the semester. We'll see about cruising. All right, so what he'll wind up doing is he'll lay out your baseline here. So let's call this one 12 plus 0, 0. Okay. And you're going to make a building that looks parallel to this. Okay. Oh, I missed a little jog in here. Sorry. Go ahead.
Are we given a setback from the road?
Oh, yeah. Yeah, there's a few things missing here that I realized that I didn't pull up this morning. Oh, that's cute. Something like that. So you're going to have a B here. This is your A. So you have to establish the parallel line for this, which means you want to shoot station 11 plus 0, 0. Or, and actually I would do both. Okay. So that you get a foresight and a back sight to make sure your instrument's on 0, 0, 0, 0, 0. Okay. And then, and by the way, as long as we're having fun here, north is over that way. Then we're going to go from B, we're going to put our instrument here. So let me draw that a little bigger all by itself. I did right here. And we're trying to shoot this way. Okay. So we're going to put, first one is B to A. So we're doing a back sight here. Okay. So we shot this way. We're going to set up here now. And we're going to shoot that way. And we're going to get baseline established for 0, 0, 0 again. All right. Now we can actually move everything from that angle to where we want to go. So clockwise around the building. Okay. So the first one becomes E. So it's what's the angle to E? Okay. Well, in this case, it is 60. All right. Then we're going to shoot to L here, and you're still at B. So what is this angle that this has got to be from here to there, but yet it's not that angle we're shooting. We're shooting this line to tell somebody where to put that. So what you want is this angle in here. Following along? Okay.
So every time you zero from the line, that's your zero.
Yeah, it's your zero. As long as you didn't touch it. All of it. If you didn't touch it, all other angles will come off that easily. Okay.
be in the road that's the actual point?
There will be a PK nail stuck in the ground with some white paint on it.
Is line
And hopefully it'll actually get down. Although, as good as Mr. Ryder is, sometimes his distances between stations is off by a foot. So.
Is line AB parallel to LE?
Line AB parallel to, no, just happens to look that way right now. But no. Good catch. Let's make that a little more
Does that make it easier to avoid?
obvious that it's not. Okay. Then we're going to go from L to M, which is over here. And the angle you need to shoot now is from B to here, which will be this angle. Okay. And you're telling people that stake's known now. You're stretching your distance from L to M is 24 feet, 88 inches, or 24.88 feet. Okay. That establishes that one. Then the really fun one is you're going back to F, which is here. Oh, red. And you're going that way. Okay. Now, if it was me and I wanted to know that was going to be F, I might just actually shoot G out here first, because B to G is going to be 60 degrees on the nose. Okay.
That still applies to clockwise rule.
Still clockwise. Yep. Everything's still coming off this angle here to there. Okay. But what it does for me is I get G laid out, then I get F, and I can check F, M to F distance. As long as it lines up on that line, we're good to go. Okay. Then we're going to go from G to K. And you're going to shoot that angle. Okay. You with me? Okay. So, and we just run around the building that way. But here's the thing I want to teach you. Okay. Not that that isn't useful to you, but it's not as easy. Let me get a ruler out here too, because this will make my life easier. Where'd the ruler go? No ruler. Josh, you really are jinxing Halloween here.
I know, right? I wasn't supposed to show up today.
Okay, no ruler. We're doing it the old-fashioned way. All right, so here's how you're going to do this. You're literally going to set up on engineering comp paper. Okay, so set up individual shots. Okay. And we're going to be working on these Monday and Wednesday. Okay. Okay. But generally, this is how it's going to look. So my first one's going to be, let's do a line here, and we're going to have A. And what I'm going to do is shoot or do a layout of what the shot's going to look like from A to B. Okay. So far, so good. Now that could be, and I write this, and the not 12:10. Ideally, party 1 gets station 10, party 2 gets station 11, party 3 gets station 12, party 4 gets station 13, party 5 gets station 14. Did I get everybody? Yeah, something like that. Anyways, so you'll know your station, okay? But ideally, they're all the same. And other than we used to make you split, we would draw half of you shoot this way, would shoot this, stop it, would shoot this way off the center line of the road and do it on the south side of the road. Because the pine trees in there, we got to figure some things out. And I got to talk to Mr. Ryder this morning about the details. As if we do, I got to redraw some site plans for you. But anyway, so this is, you can think about this as shot AB. And what you're really establishing is what's the azimuth of AB, right? Except our 0 is over here. So we have, this is no joke, let's put this in as 11 plus 0, 0. We have a known azimuth of 11 plus 0, 0 to 12 plus 0, 0, which will be your 0 degrees, 0 minutes, 0 seconds. Okay, so you do have to get your instrument set up, get it leveled, get it all sorted out, shoot that way, and get a measurement, come back, and what you're shooting for is the pin or the PK nail in the asphalt at the other end. Okay, so you can do the same thing you've been doing with the PK nails up on the hill and the stakes, except it's in the ground. Okay, so that'll give you your line there. Now, if you want to check it, spin it around and check the other one. Okay, foresight, backsight kind of stuff. We verify everything by double checking. Okay, so then we actually go through this whole process of figuring out what this angle is going to be. So we get the angle of A to B to be 120 degrees, 0 minutes. Okay. And then we will go to the next one. We will do shot B to E, okay, and that'll establish first an azimuth of B to A as a new 0, okay, and then we figure out what azimuth B to E is, okay, and that one should be 60 degrees, 0 minutes, 0, 0 seconds. Pretty straightforward, okay? But we're going to lay this out piece by piece. And I will spend the time helping you do all these little drawings, okay? Because without these, you're clueless. And coming up with the stuff I showed you in the book will be difficult to do. Make sense? Okay. Questions on why you're doing this and what you're getting out of it? What are we doing on time? That was quicker than I thought. Okay. So come Thursday, you'll have it all, well, you'll have it mostly done. There's stuff you're going to have to do for homework. I'm going to get you started, and you're going to solve some of them. Okay. Which, Brett, going back to your question, yeah, by the time we get all done, everybody's numbers should be the same. Okay. So the field books ought to look identical. The real trick to this is the work that goes in behind the scene versus the day you're out there. Okay. So far, so good? So I would, personally, I'd get Lab 10 down, get it printed today or Monday morning. Monday, we'll start doing the layouts by section. Okay. We'll start working out the angles. So bring your calculators because you're going to do all the math.
board class?
Do you have comp paper fours or should we grab some?
You don't have comp paper. I will bring you a pad down.
I got some.
You want to try and do the lab from yesterday? Or do you not have time?
I have time.
All right.
Have a good week.
I will try.
I
You want to know where